So again, our special centers we found so far, we found the circumcenter, right? That's the perpendicular bisectors, and it's equidistant from C to D, C to E, C to F. So the circumcenter is equidistant to the vertices. In center, found using the angle bisectors, it's equidistant to the sides of our triangle, the sides, okay? And the last one we're going to look at today is something called, we're going to find the centroid. Centroid. Okay, kind of sounds like droid or something like that, right? It'll just be one triangle. Yep, exactly right.
Should we do this in the back?
I'm going to do it in the back because I ran out of space in the front. I didn't have enough space to do it there. So the centroid. Oh, you should have plenty of space, yeah. The centroid, okay, it is found using the medians of a triangle. Okay, now, the word median you have heard before. Okay?
Median.
So, right, the medians, okay, or when you find the median in, like, data analysis, okay, how do you find the median in data analysis? What do you do with your, like, numbers?
Oh, you take that and divide by how many letters?
You add them up.
Okay, so adding them up and dividing by the number of numbers, that's not the median, that's the mean. Be careful. The median is when we do what, Krishna?
You line them up in numerical order.
Put them in order from least to greatest,
That's what I said.
and then find the middle number. Okay, but it's still the same idea. Mean and median and mode, right? Those are all three measures of central tendency. It helps us find the center of our data. Well, the median, okay, of a triangle, a median, okay, is a segment joining a vertex of a triangle, okay, with the midpoint. There's that middle idea, okay? So again, a segment joining a vertex of a triangle with the midpoint of the opposite side of the triangle, or just of the opposite side of the, opposite side. Okay, so a median is it's a special segment, just like an angle bisector, just like a perpendicular bisector. A median is a segment that joins the vertex of a triangle, or a vertex of a triangle, at the midpoint of the opposite side. Okay? So, let's draw a triangle here.
And this is the only one we're doing in the back.
This is the last one we're doing on the back. Yep. Okay, so there's my triangle. I'll call this triangle LMN. Okay, we're working our way to the alphabet there, I guess. Okay, so to draw a median, it says that we need to make a segment that joins a vertex of a triangle. Well, a vertex is easy to find here. We got 3 to pick from. I'm just going to pick vertex M. So our segment, our median, will connect M to the midpoint of this opposite side. So I'm going to connect M to the midpoint of LN, segment LN. But how am I supposed to find the midpoint of this segment? What construction could I use to find the midpoint of LN? Yeah, the perpendicular bisector construction, exactly right. So let's go ahead and do the footballs, but then stop. Don't draw on the perpendicular bisector. So go ahead, do the footballs to one of your side, do the football construction to one side, but don't actually draw in this segment yet. So I'll go ahead and do the football construction. Yep, a little more than halfway. And Skylar, if you don't do it more than halfway, you'll see what the problem is. They'll never intersect, and that's why it's got to be more than halfway. So. Okay, so do your football, but then stop. Don't do anything yet. Okay. So just get your football in there, just like that. Okay. Now. Okay, sorry, I'm going too fast. I'll slow down. Okay, so make sure you get your football on the one side there, but don't draw in the perpendicular bisector. Yeah, medians. And then the other vertex, L, there you go, and then do your football. Okay, so, now that you have your football drawn in, okay, what we would do at this point, what we used to do at this point, right, is we would take our protractor, or our straight edge, and we would draw this segment. But we're not going to do that, because if I do that, what special segment will I be drawing? We're going to be doing the perpendicular bisector, and the perpendicular bisector finds the what? The what special center? Circumcenter. Do we want to find the circumcenter?
No.
So should I draw perpendicular bisectors? No. So then why do we do this? Because I just want to find the midpoint. So you still line up your protractor, your straight edge, like you're going to draw it in, but then you just mark the side for the midpoint. That's it. So that's all I do. Just mark the side for the midpoint. Okay?
Just for the little line.
Just where it would cross, find that midpoint, and there it is. There's the midpoint. And you can, if you want, you can even like show that's midpoint by putting a little tick mark there, a little tick mark there, right? That's going to be congruent. And now that we have the midpoint of the opposite side and we have our opposite vertex there, now we're going to join M with that midpoint. So here's how we draw that special segment. We're just going to connect from M down to the midpoint like that. And that is a median. That's a median. Yeah.
That's it?
That's it. It's good. I'm glad you think that, right? So, yeah, the good news about this one is we already know the basic construction for it. We just have to make sure we don't get it confused, right, with perpendicular bisector. Notice the median does not intersect where the perpendicular bisector would be. The perpendicular bisector would look like this. I'll draw it from this side. If you see here, look, my perpendicular bisector is not the same thing as the median, so do not confuse the two. Okay, my perpendicular bisector would go right along the side of my protractor right here, not where that median is. So they are two different segments. Even though we use a similar construction, they are two different special segments.
And that's all we had to do.
So, well, we've done one. Now, how many do we have to do?
Two.
We got to do two. Yeah, we got to find another one so we can figure out where they intersect.
So do we erase that?
So I'm going to erase back some of these arcs because again, it can be too much. You don't have to if you don't want to. If you're fine with like keeping it all straight, go for it. I'm going to erase it back some just because it's too much. Okay? And then just pick another side and do your football construction. So I'll pick side LM here and do it there. Okay, and like I said, I like to turn my paper so that LM is facing me. Point on M. Okay, and we'll do an arc there. And then point on L. And an arc there. Okay, so once again, you got your football construction. Okay. And now we have that football construction. Remember, we do not draw in the perpendicular bisector. Do not draw the perpendicular bisector. Just use it to find the midpoint. Right there's my midpoint. Again, you can mark both sides congruent there. So again, straight edge down, just mark the midpoint. That's it. Do not actually draw the perpendicular bisector. And again, I like to mark the two parts congruent there because we know they're going to be congruent. Okay. And then we're going to join the midpoint. In my case, I'm going to join this midpoint to what vertex? N. That's right. If you did a different side, then you might be a different join it up there. We're just going to join it from N to there like that. And where the two medians intersect, right there, that is where the centroid is located.
So we're going to draw like a centroid or something?
What's that? It feels crooked? Yeah, it looks okay. Again, just make sure you're going to connect N to the midpoint there. It should be okay. I think that's okay. Just watch your protractor there. You want to make sure you get it lined up. Yeah, so remember, it's not a perpendicular bisector. You're just joining that point to the vertex. That's it. Okay, now, what is special about this? Okay, so let me go through a few things here. One special relationship is that this centroid here, and I'm going to go ahead and name this midpoint here. I'll call it like O. Okay, and this is going to be good for us here. Okay, so this centroid this median MO. Okay, the length from M to O, that length. Okay, and actually let me call the centroid here point C as well. So let's call this midpoint here O that M connects to, and then we'll call the centroid C. Okay. So here, this length right here, CO, is equal to 1/3 of MO. Okay, so this length from C to O here is 1/3 the length of the full median. Okay, so from C to O, that is equal to 1/3 of the full length of MO. And so if C to O is 1/3 of MO, what do we want to say that M to C is? 2/3. 2/3, right? 2/3.
Wait, how did you figure that out?
So how did you figure that out, Skylar? How did you know that? If again, let me start her out. If C to O is 1/3 of the full median, then how did you figure out that MC had to be 2/3? Shh. You want to have 3 out of 3 for the full length here. So if this is 1/3, Jason, the rest of the segment has to be 2/3, because the 1/3 plus the 2/3 will give you the full segment there. So yeah, MC is 2/3 of MO. Yes, so that means then, if I were to look at this segment right here, this median, and again I'll call, we'll call this one P maybe. Okay. So here, CP will be 1/3 of what? PN, or NP, whatever you want to say there. Yeah, so CP is equal to 1/3 of PN, or NP. Okay, right there. And then CN, or NC will be what relationship to NP?
Oh, 1/3.
Not 1/3.
Oh, 2/3.
2/3, yeah. So
yeah, how do we know what start to, where to start?
which one's 1/3, which one's 2/3? Yeah, the smaller piece will be the 1/3, exactly right, and the bigger piece will be the 2/3.
Okay, I got it.
Yep.
I understand.
Good. Okay, other questions on that?
Is it always going to be a 1/3 and 2/3?
Yes. For the median, for the centroid, it will always be that 1/3, 2/3 relationship. So that's a little bit different. Remember that the in-center, right, is equidistant. It's the same distance to the sides. The circumcenter is equidistant to the vertices, but in the centroid, it's a little bit of a different relationship there. These parts, one part's the 1/3, one part's the 2/3 of the full length there. Okay? There's one other special property of the centroid. The centroid is the center of gravity of the triangle. It's the center of gravity of the triangle, or you could also call that the center of balance. Okay? So what that means is, if we were very precise in drawing our medians and finding our centroid, and if we were very precise in cutting out our triangle, then this triangle would balance on a pencil point or something like that. Right at that point, that's where you'd put your triangle, on top of like a pin or a pencil, to make the triangle balance. But you have to be very careful about cutting this out very accurately, and then also very careful about drawing your medians accurately. Okay? But it should balance right around that point. That's the center of gravity of the triangle. Okay? So it would not tip off to one side or something like that if you balanced it. Okay? I actually tried drawing one and cutting it out before, and I messed up because I guess I'm not accurate enough for it, but it should have balanced, but it didn't. Also, there's like wind and stuff like that, but anyway. Yeah, Scott. No. I just wanted to put that in there for your own benefit there. Okay? So, if you guys would please get out your books, and we're going to look at some problems, okay? Get some practice with this. Sir, you're welcome. Okay. So please turn to page 383. Yes, sir.
Am I allowed to store my papers up in here?
I would prefer that you keep them in your desk because I can't guarantee, Jason, that someone won't take them or do something to them. Well, they might do it to, you know, like troll you or something like that. They might like recycle it, throw it away. So page 383, please, in your books. Page 383, please, in your books.
Can I rip this out of other pages? Okay.
If you want to rip it out, it'll be 383 up through, and we're not going to do all these, Jason, but 383 up to 391. But we're not going to use all of them. Okay, as we go. Okay. So we'll start on 383. Okay, we're all there? Okay, so page 383, let's look here. So we've got the centroid theorem. Okay, this is what I just talked about here. The centroid theorem states that the centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. So for example, here we have a median, AX, okay, and then if we call the centroid P, then A to P, right, is 2/3 of the full length AX.
Yeah, because X is smaller.
Exactly, because that side's the smaller, right? Exactly right. So PX then, so AP would be 1/3, PX would be 1/3 of the full length AX there, okay? So same thing here, right? Again, we have a median BY. So from B to P, that's 2/3 of the full length BY. So BP is 2/3 BY. And then here as well, CZ is one full median. So from C to P, that's 2/3 of the full length CZ. Okay, so let's look at some actual problems here. So in this first one, example 1, it says use the centroid theorem to find the length. Okay, and so in this case, we are asked to find AG, and we have some information here. AF from A to F is 9, and C to E is 7.2. So if I want to find AG, okay, that's a part of segment AF here. So what fraction of AF will AG be?
2/3.
2/3. So if AF is 9, we're going to do 2/3 times 9, and that will equal AG. AG is 2/3 times AF there. So 2/3 times 9. Okay? Now, believe it or not, you guys might be like, oh, fractions, I hate these things, I'm going to calculator out. You guys can do this without your calculator very easily. Let me show you. 2/3 is the same thing, so 2/3 is 2/3. 9 is 9 over 1 as a fraction, right? When you multiply fractions, how do you multiply fractions?
2 times 1 and 3 times.
We don't cross multiply, nope. We just multiply across the top. 2 times 9, so it's 18 over 3 times 1, 3. And what's 18 over 3? It's just 6. See, there you did it. I'm sorry, it's cut off the screen there. So that was it. You just did some fractions. And of course, we can see there's the answer right there too, because it worked it out for us as well. Okay? Now, the top of the next page, it asks us to find GE, but I'm going to do GE work here because otherwise we won't be able to see it. So I'm going to zoom out just a little bit. Oh, does it say CG? No, on the top of the next page it says GE is what it wants us to find. So let's find the measure of GE. I'll put the B part right there. Okay? So GE, okay, that's part of the big median here, CE. Okay? Now GE, is that the 1/3 part of CE or is that the 2/3 part of CE? It's the 1/3 part. So GE, okay, sorry, I'll write this. So GE is equal to 1/3 of CE. What do we know CE is?
CE is 2/3.
So CE is a full length of 7.2. So the full length there is 7.2, so we plug that in. Okay. And so 1/3 of 7.2, now this one's a little bit trickier because you got decimals and fractions. You can definitely use a calculator for this if you want to, but it's going to be 2.4 when we finish up there. Okay, so 2.4. To do fractions in your calculator, if you have a graphing calculator, don't forget, you can put parentheses around your fraction and then multiply by the decimal there, and then you get the 2.4. Okay. Questions on any of that? Oh, sorry, Ramel. Okay, so you'll have some of those for your assignment here once you get done. I have one more thing I want to show us. Excuse me, and then I'll give you guys your assignment. Okay. Let me know when you're done there, Ramel. Okay? So again, this is the one thing for the assignment, and then we'll look at the other one in just a second. B, I don't know, for whatever reason they show it such a different way, and it's so silly to me, not needed. They make it more complicated. I think, you know, because it's basically because in the book they don't have you like see that the other segment then must be 1/3, like you were able to figure out. So, but we can figure that out. So why bother? Okay. Next thing, one last thing here I want us to be able to do is to find a centroid in the coordinate plane. Okay. Now, Jaden, I think, right? Didn't you say that you didn't like these because they're in the coordinates, or maybe someone else? Okay. It's a lot of segments and stuff going on here, but again, it's the same principle. And in fact, okay. You guys are good at this. You can like just eyeball this to a degree. So for example, okay, we're asked to find the coordinates of the centroid of the triangle shown on the coordinate plane. So here's our triangle. Listen up, please. Okay, so to find the centroid, that means you need to come up with the medians. And remember that a median connects a vertex with what? The median connects a vertex of the triangle, so QP or R here, connects that with the what? Midpoint of the opposite side. Okay, the median connects a vertex with the midpoint of the opposite side. So, okay. So point P here, let's just start with that vertex. If I'm using point P, then that means which... Derek, right now, where's your book? Get it out, please. We're on page 385 so you can follow along, okay? If I pick point P, then Gabe, which side am I going to find the midpoint of? If I'm going to connect P to the midpoint of the opposite side, what's the opposite side from point P here, Gabe? In the picture. So if this, so like we got our triangle right here. You see the triangle? Triangle QPR there? Okay. If I pick point P to be the vertex, to draw my median, I need to then connect that with the midpoint of the opposite side. What is the opposite side from point P? Yeah, QR, exactly right. So I have to find the midpoint of QR here. Okay? Now, if this is too difficult for you, you can always, you know, do your perpendicular bisector construction, find the midpoint. But I bet some of you guys can eyeball in the picture here where that midpoint is. Can anyone eyeball where's the midpoint? At what coordinates? At 3, not 4, 3, 6 is the midpoint of the opposite side. That side, 3, 6 would be the midpoint right there. What this actual centroid was? Okay, we'll get to that. Don't worry. I want to do this first, though. So yeah, 3, 6 is the midpoint, so then we'll draw the median here. Okay, like so. Without even having to do our construction because it's in the coordinate plane, so it's kind of easy to eyeball that. Okay? If you're unsure, but like how we get that, well, just take a look here. We had to go down to right 3, and then from this point we go down to right 3 as well. So that's got to be the midpoint then. Down to right 3, and again down to right 3, that's going to be the midpoint right there. Okay? Good. All right, so let's pick another point here. So let's see. How about... No, he's not here. Yeah, right? So Garrett, pick another vertex. Okay, sorry. So we already did P, so pick another vertex there when you... R, great. So that means we want to connect R to the midpoint of what side? QP, exactly right. So now this one's a little bit trickier to find the midpoint, but can anyone eyeball that? What is the midpoint of QP? What will be the coordinates there? And this is a little bit hard to see because it's not exactly on a coordinate, but it's, you can still, I bet you can still do it though. Someone can come up with it here. So the y-coordinate will be 4, and then yes, the x-coordinate, who are exactly right, will be 1.5. So yeah, it's right there. Right there. Okay, you can kind of see it's right in the middle. Okay, and then we'll just connect R to that midpoint there. Okay, and then so what are the coordinates for our centroid?
It will be 3, 4.
3, 4. And Haley, you were right. Good job. Who wants to get done? Okay. So again, if we were to very precisely cut this out, okay, if we were to then, you know, if we found, actually that's very precise there. So if we were to cut that out very, you know, carefully, and we would be able to balance the triangle on that point right there. Okay. So there we go. Okay. You can also see here, for example, in this median, the 1/3, 2/3 relationship. What is the length of this median right here? What's the entire length of this vertical median that I have drawn in here? It's a length of 6. And so what's 2/3 of 6? Well, it looks like it should be 4, right? And that's length of 4. And that's what's 1/3 of 6? That would be that. It's 2. So, and they sure do match up. Okay. All right, very good. So that is all we have to cover today. So I'm going to get you guys started on your assignment, okay?